Number one from, this is number one from Unit 12. It says 2 sine of x minus 1 equals 0. I'm going to add 1 to the opposite side and then divide by 2. Basic algebraic operations. Again, sine is like your y value. Sines are only positive. In Units 1 and 2, you are allowed to use this on your exam. Sine is the second. If you have a hard time, remember it's CBS, cosine before sine. So we can see that sines are positive at 1/2, which is at pi over 6, and over here at 5 pi over 6. And those would be my two answers. So for number one, correct answer is A. Let's look at number two. Number two says 4 cosine squared x minus 3. There's not a lot of difference between 1 and 2, except for now we have a trig function that is squared. Here we go, number 2. So I'm going to do the same procedure. Remember, we add or subtract first and then multiply, divide if necessary. So I add 3 to the opposite side, divide by 4. How do we get rid of the square? I'm going to square root both sides. Also remember, that means I'm going to have two answers. That's why you see a plus or minus. The square root of 3, we don't know, it's irrational. The square root of 4 is 2. So cosine CBS, I'm looking on the unit circle and I'm finding the first number in the ordered pair, that is radical 3 over 2. Remember, it was plus or minus, so we can see this location and this location, both 30-degree reference angles, but at pi over 6 and 11 pi over 6, we both have positive radical 3 over 2, and negative radical 3 over 2 can be found at 5 pi over 6 and at 7. So correct answer for number 2 is option B. Let's look into option number 3. Right away, what I noticed different than 1 and 2 is we have a 2x instead of just x. That means you're going to do 2 complete cycles or revolutions around the unit circle when we identify. So the initial problem for number 3 was sine of 2x equals negative 1/2. And so all I need to do is I need to take this answer and ask myself, where is the sine equal to negative 1/2? Keep in mind that sine, again, CBS, sine is the second number in the ordered pair. Now we're going to do 2 cycles of it. So let's first just identify where in the unit circle can we find a negative 1/2, a negative 1/2. And you're looking up here and you're saying, why did I put the dots up here? I should be crossing those out. And that's because initially I didn't see that there was a negative sign in this problem. So we can come back over here and see that my answers are actually over here at my 30-degree reference angles. But let's look right now. Let's find where's the sine equivalent to negative 1/2. Again, sine is always the second number, CBS. So negative 1/2 at 11 pi over 6 and also at 7 pi over 6. So I take the 2x, I set it equal to 7 pi over 6, and I set it equal to 11 pi over 6. Now, how do we go about solving for x? When you divide by 2, you're just going to take the denominator times this outside number. That's how it becomes 7 pi over 12. Likewise, we have 11 pi now over 12. This is an 11. Remember, I had previously at a different number because I didn't realize there was a negative. Okay, we just did one cycle. We did one cycle around. Now we need to do the second cycle around, second cycle. Now, real quick here, just to teach you a little trick here. We are working with 30-degree increments, right? We know that we are working with 30-degree increments. How do I know that? Because 7 pi over 6 and 11 pi over 6 have a reference angle of, excuse me, have a reference angle of 30. So there is 12 of these sectors, or if you think about pieces of pie, when I do one revolution. And so if you're wondering where they are, we have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, and 12, 6. So one revolution is 12. Now my answers were here at 7 and over here at 11. Now let me just watch. I'm going to show you how to do it the slow way. So I do one cycle, and these are my answers right here. And now the second cycle. Here's 11, 12. I need to keep going. 13, 14, 15, 16, 17, 18, 19. So I said there's 19. Keep that in mind. 20, 21, 22, 23. So 19 pi over 6 and 23 pi over 6. That's where I came up with 19 pi over 6 and 23 pi over 6. Again, you set it equal to 2x. Now, why am I doing this 4 times? Because there's 2 places that have a negative 1/2 as a sign when I do the first cycle, but I have to do 2 cycles. That's why I came up with each 4 of these. You set 2x equal to each one of these radian measurements, and then the same thing, we get 19 pi over 12 and 23 pi when we divide by 2. you're really multiplying by the denominator. Is there a quicker way? Absolutely. When you have 30-degree increments, you're simply going to add 12 to the numerator. So 7 plus 12 is 19. 11 plus 12 is 23. The correct answer for number 3 is D. Let's look at number 4. Now, number 4 reminds me of number 2. We have a trig function, and it's squared. We're only looking at one cycle around. I'm taking this original problem that's provided to me. First, I'm going to add 1 to the opposite side, and then I divide by 3. To get rid of the square, I'm going to square root both sides. Keep in mind, this means I'm going to have 2 answers. So I square root both the top and the bottom. We know the square root of 1 is 1, and the square root of 3 is irrational. Now, mathematically, this isn't wrong, but we need to rationalize the denominator. Is there a quick way of doing it? Yes, there is. Take this, you're going to copy and paste it up top. So 1 times radical 3 on top is just radical 3. And then you're going to keep the number all by itself without the radical on the bottom. Okay, let's look back to what I provide you, and let's look where we can find the square root of 3 over 3 for I've identified them here in purple. They are on your paper as well, and it appears right here at each one of the reference angles of 30 degrees. So the positive radical 3 over 3's occur at 1 pi over 6 and at 7 pi over 6. The negative radical 3 over 3's occur at 5 pi over 6. And the correct answer to number 4 is C. Let's look at number 5. Radical 3 secants plus 2 equals 0. So this is the first time in the problems that we have done in this review in which we have seen a function that is not one of the common. So the common sine, cosine, tangent. Now this would be the reciprocal. So think in your mind, what is the reciprocal of secant? I always tell kids it can't start with the same letter. So if this starts with an S, the reciprocal is not sine because they both start with S. So this reciprocal is cosine. Keep that. Okay, first thing I'm going to do is subtract 2 to the opposite sides. It's negative 2, and then divide by radical 3. Remember, secant is reciprocal of cosine. So if I flip this around, I'll have the cosine. So cosine is the reciprocal of this secant. So here's my cosine. You keep the same sign and just flip it around. Let's look at the unit circle, and let's identify where the cosine is negative radical 3. So cosines are like x values, and if it's negative, I know it's going to be in quadrant 2 or 3, and here we can see negative radical 3 over 2 and negative radical 3 over 2. The two answers would be 5 pi over 6. And let's go ahead and look at number 6. Correct answer, by the way, so number 5 is B. Let's look at number 6. So I see 2 different factors, and it sets equal to 0. So if this is a true statement, if the left side equals the right side, then one of 2 things, and actually one of 3 things must be true. The first factor must be equal to 0, the second factor must be equal to 0, or either they both equal 0. So let's identify what x. First step will be to take each of the provided factors and set it equal. Then on the left-hand side, I'm going to add 1 to the right-hand side. 0 plus 1 is 1, and subtract 1, 0. Now let's ask ourselves, where is the sine is equal to 1 at pi over 2. Where is the tangent equal to negative 1? The sine, again, here we go. I can illustrate. The sine is 1 here at pi over 2. So remember, for tangents, all-star trig class, the tangent is 1 at pi over 4 and at 5 pi over 4, but we're asked where is it negative 1. It is negative 1 at 3 pi over 4, and again it is negative 1 at 7. The correct answer to number 6 would be option A.